the video presentation for Machine Learning Foundation for Product Manager on Coursera. Okay, so the project definition is to build a model to predict electrical energy output of a CCPP, which use the following to generate power: gas turbine, steam turbines, and heat recovery steam generator. We have the data set with 9,568 record of hourly average ambient environmental reading from the sensors. And the data set including the 4 features of temperature, ambient pressure, relative humidity, exhaust vacuum, and the target is to predict the net hourly electrical energy output. Based on the features and the output we have from dataset, this is a linear regression versus classification regression. So we will taking the linear regression modeling as the direction. Also, a typical linear regression represents, predict a continuous value and the relationship between independent variables and the continuous dependent variables are approximately linear, and also each feature has a weight. So in terms of the approach, it is a the best option would be multiple linear regression, or even to see if it's necessary to build a lasso or ridge regression. So we'll start with the multiple linear regression, including all of the 4 features provided by the data set. So I using Excel, and then have the 80% of the data as the training data and the 20% as the testing data. And when I including all the 4 features, the evaluator I pick for this project is R square. I got 0.9296, which is pretty excellent. And then based on the how much of a impact of all the 4 features, I evaluate that is the temperature, and this is the P, and then this is the V, and this is the AP, and this is RH, and then we can see the AP and the RH are relatively low coefficient. So in the module, I exclude RH, the lowest efficient start with, and I got a little bit lower R square number, and I tried to exclude AP and got even lower number, which means that the best and most efficient way, effective way to have this multilinear regression would be including all the 4 features. And based on this conclusion, we will not go into ridge or lasso regression because of it, because based on the result. So by evaluating that, and then the model will be including all of the 4 features, and then this will be the formula to predict the output PE. The 455, that is the intercept from the multiple linear regression model show here, and then with each coefficient for each feature. And then the final model based on that, and then I use the formula to come up with the predictive PE as input, and then compare that with the actual value um, and I got R square as 0.9248, which is also really good. So this is the final module. Thank you.